So today we are going to solve a problem of longest binary subsequence less than or equal to k. So in the question we have given an string which is binary in the binary form, and we have given an integer k. So we have written the length of longest subsequence of s that make the binary number less than or equal to k. So and the subsequence can contain leading 0. It means we have contained the 0 in the front of string. So what actually question mean? Suppose we have given this binary string, we have this string and we have k given 5. So we have to find the maximum length of subsequence whose number is like 1, 2, 3, 4 and 5, which is less than or equal to 5. So the first approach is we have to complete this question in a big O n time, and we will use O1 space. So this is our constant and we will do that. First of all, we see how we can convert the binary number into the decimal number. The simplest approach is we can use the 2 power, like here we initialize 2 to the power 0, and every time we increment the 2 power. So 2 to the power 1 for that, and for this 0 we can say 2 to the power 2, and for this 2 to the power 3. Similar, we have 2 to the power 4, and this 2 to the power 5, and this is 2 to the power 6. So if we calculate the whole string, we can generate the whole decimal number. So if we multiply 0 from 2 to the power 0, we will get the 0, and if we multiply 1 to the 2 to the power 1, so what we get? We get 2. So it means that from here we generate the 2 number, that is 2 plus 0, that is 2. Okay, and from here 0 we multiply 0, so everything will be 0, so it's 0, and that is 1 to the power 3, that is 8. Okay, so 8 will be there, but you know it's greater than 5, so we will not include this. Okay, and we will see 0, everything would be 0, so it would be 0, and it would be also 0, and it will be also greater than 5, so we will not include this. So from this approach, what we can say that we will iterate our loop from this side. Why this side? Because if we see number like this, like for example, if we see what is the binary number of 1, so the binary number of 1 is 1, this, and if we see this binary number, the decimal value is also 1, and if we see this, the decimal value is also 1. No matter how 0 are including in the front of that string, so but the length of sequence is 1 here, and here 3, and here 5. So we can say it is our best answer. Why? Because the length of sequence is 5. So instead of answer this, we have correct answer this. So we can say we can iterate our loop from the right hand side to the left hand side, because it's include 0 on the right hand side, like it's include 0 at that side. And what is our approach? Suppose we take the example like 0 0 0 1 0 0 0. By the way, we can also include here 0, because it is also less than k. So here we suppose that k is given 1. So what will be the possible value? It would be 0 or 1, less than, like we have less than k or equal to k. So for every 0, like our iteration is here, so for every 0 we make a variable count, which will give the length of subsequence. So initially it's 0, and our value will be initially 0. What will be the value of count? Count basically give the how many we have included the element in the our subsequence. And what is the value, what is the work of value? Value will be iterate the current value, like initially we have 0, so whenever we see 0, we every time we increment the count. So our first condition is, if our s stored character at I is equal to 0, so every time we increment the count. So like our count basically here 2 to the power 0, it means 0, and for average 0 we have 1, so here the condition satisfies 1, and here it's basically 2 to the power 2, and when our iteration come here, so basically if s stored character equal to character at I equal to 1, so what we can do, we can calculate the number till here. And how we calculate the number till here? We can just add the value, like we can say our value would be value is equal to value plus math dot power. We can use the power function in Java, and we can use any function whatever you use in Java, in Python or C++ you can use. So what we can use, we can just multiply 1 into the 2 to the power 4. Okay, so what we can say, we can multiply 2 to the power count. Okay, so if this value is less than equal to k, that means if this value come less than equal to k, so we can increment our count. That means we can increment our count, otherwise we just pass this round. Okay, and when the value is coming here, it is obviously greater than 1, so we will not include this number, and so we will next go to the 0 here, so we increment the count, and then we increment the count again, we increment the count again. So what will we do? We can say our answer would be 6. And what is the subsequence? Subsequence is 0 0 0 this and this, and its number always form 0, so our correct answer would be this. So its time complexity basically is big O of n, and its space complexity is big O of 1. Let's see the basically code, how we can do the code. In the code we do the simple thing, like if character equal to 1, so we just check if the value plus mass power and count is less than or equal to k, so we can increment the value of v, and we can also consider that number in our subsequence. That's why we increment the count, otherwise we will not increment the count. And if character is equal to 0, or we can say if we have only two number, either 1 or 0, so we can put the else condition, then we can directly increment the count, and after that we directly return the count, and its time complexity is O(n). So it is the most efficient solution.